students, today we will study chapter 10, visualizing solid shapes. So we study many types of shapes. Some shapes are two-dimensional, and some shapes are three-dimensional. For example, two-dimensional shape, the shape which we require a rectangle, square, circle, triangle, which we represent in the surface, is called two-dimensional, while the shape cone, cylinder, cuboid, which we require to represent three direction, is called three-dimensional objects. So the two-dimensional object will be represented in the surface, it will be look at same as, but three-dimensional objects will be seen different from the different direction. It has a three types of view: top view, front view and side views. So you all can see the three views of the different object in the textbook. It is given the house, three views we see, then top view we can see like this way, the roof only will be seen like a book. Side we will see, then we will see the window and the wall, and front view we will see, then we can see the door and the front wall of the house. Same way a glass we see, then it has two views only, side view and the top view. The side view will be seen, it is like this way, glass shape, while top view we will see, it will be seen the circle shape. Same way we can see the top part of the brick, front part of the brick and side. So from this we can see that this smaller rectangular part will give us front view, the larger rectangular part will give us a side view, and this part will give us a top view. So same way, if we arrange the block and its different view we see, then side view only two bricks will be seen, so it is shows two bricks. Then front view will give us a L shape, so L shape is the front view, and the top we will see then this one block and one block, so it will be look like two blocks are together. Same way here another blocks arrangement is given. In that the front view will see then this block and this block will give us a two block is a rectangle form. The top view we will see, in front view two blocks are there. Top view we see, then four blocks will be seen like this way shape, and the side view we will see then three blocks in a line we will see. So same way here another front view will give us only three blocks in a line, top view will give the T shape, and the side view will give one, and backward block two block will be given. So here exercise 10.1 is there, match the object with its top view, front view and side view. So we can see a bottle, its side view is here and top view will be round shape. Same way 5 kg weight, so it is pentagon, and so its side view will be the rectangular faces, so this is the side view and this is the its top view. Now a flask is there, so we can see that a cylindrical shape is there, so side view is here and top view will be circular. A cup and saucer is there, so cup and saucer view, side view is here and top view will be circular. And the container, side view will be rectangle and top view will be small rectangle with circle cap. Now the question 2 is there, we have to write which view is there. So we can see mirror and that is the front view. This longer rectangle part is the side view and smaller rectangle part is the top view. Same way in the matchbox, this part is gives us the side view, this part is gives us the front view and the top part is the fish, so this is top view. Same way in the television, the glass and that part is gives the front view, this part gives us the side view and the top part will be this. Same way in the car, two headlights and these parts are shown, so this is front view. The side view we can say like this way, so this is side view and the top part will be the roof. Here also block arrangement is given and given that said write the top view, front view and side view. So this is the L shape which we can see in the top part, and so it is the top view. In the front it is a two side rectangles are there, so the and side both the views are same, so one is the front view and one is the side view. Same way in the B figure, three rectangles are there in the front we can see, so this is the front view. From this side we will see then two blocks we can see, so it is side view and the L shape is the top view. Now this T shape is given from top we will see, then only two blocks will be seen, so two block is here top view. Now from side we will see three blocks in the straight line will be seen, so this is the side view, and from top front we will see then it is seen vertical T, and so it is front view. Now D figure is given, from the top we see then three blocks will be seen, so straight three block is the top view. From the side we will see two block only will be seen, so side view, and from the front we will see this way shape is there, so it is front view. Now E shape is there, so from the top we see only this way we can see, so this is a top view. From side we can see this part, and so this is the side view, and from front we see, and so this is the front view. Now we will understand mapping space around us. So we are making picture and map. So here one of the picture is given, its places are represent. This picture represents the position of the object nearby us, but it does not give the perfect idea. By looking this picture we can see this is someone's house and how it is, but if this part we see we cannot understand what it represents, just it is a line. And so when we represent a map we need to see that how it looks. We need to represent around its perspective, like here one of the map is given. Raghav has made the one map, the route of house to sister school, and his school is represent, and between some objects are coming, that is represent, but we cannot understand what these objects are representing. So when we do the mapping we need to do exactly measurement, means some proportional of the ratio we have to take, and we need to draw the map. Like here whatever a picture is there we are representing on the small paper with the proportionality of the distances, and so we select some scale and we draw, then it will be clearly we can understand through it. And we need to represent some symbols, not like this circles and square. And so here we can see in the another map, here symbols are written, these symbols represents the school, this hospital, and like this way. So anyone can understand by figure 10.3 what this represents, from where to where Raghav's sister school is, how much distance at home from home, and what is the distance of the Raghav school. Where is the petrol pump, where is the hospital, everything can be understand, even distance are written. So whenever we map some space around us, we need to represent with the some distance scale all the roads and everything, and even each building has the different symbol has to be given, so we can understand very easily here hospital is there, here school is there, like that way map should be represent. So to summarize the map, a map depicts the location of a particular object place in relation with other object place. When we prepare the map, we have to see that in the comparison in the relation of other object place, the particular object place should be represented. Symbols are used to depict the different objects, so we need to use the symbol. There is no reference or perplexity in map. Objects that are closer to the observer are shown to be the same size as those that are further away. For the example, look at the following illustrations. So as it is a position, we need to represent it. Maps use a scale which is fixed for a particular map, and for the map we need to prepare the scale, and according that scale only we need to draw the map, so we can understand its distance and proportionally distance to clear. Now exercise 10.2 is about drawing maps, so you all can do yourself. Different map you are there. Draw map of your classroom, draw map of your school compound, and giving instructions. So this work you all can do yourself. Now we understand about the solids. So solids has the faces, edges and vertices. So what is the face, what is the edge and what is vertices? So the rectangular or the plane figure in the front, it is called face. Where the two faces are meeting each other, that is called edges, and where edges are meeting each other, that is called the vertex. So each of these solid is made up of polygon regions which are called its faces. Means these polygon front surfaces are called faces. Faces meet each other at edges, so the lines are called edges, and the edges meet at each other, the vertices. Now polyhedrons and not polyhedrons. So the solids which have the surfaces are in rectangular and triangular shape are called polyhedron, while the surface solids which do not have a edges and vertices and the curved surfaces are there are not called polyhedron. So we can see here the non-polyhedron has the curved surface, no edges, and no they have the base and lateral surface area, while the polyhedron has the edges, faces and the vertex. Now we will study about convex polyhedron. So the polyhedron which is opening outside are called convex polyhedron, while the polyhedron which are opening inside, which has the curves inside, are called concave polyhedron. So regular polyhedron, a polyhedron which has the regular faces, means all the faces are equal, like say a cube, and the number is said to be a regular if its faces are made up of regular polygons and same number of faces. It has the same number of faces at each vertex, means the three faces are at each vertex here meeting. Now we study about prisms and pyramids. So prism, the top and base is the parallelogram, means the equal shape, congruent shape, and the another faces are parallelogram, then they are called prism. While if in a one vertex they are meeting edges and the base is the any surface or any shape, then we can say that pyramid. So we say that a prism is a polyhedron whose base and top are congruent, and polygon whose other faces are lateral faces are parallelogram in a shape. On the other hand, a pyramid is a polyhedron whose base is a polygon and whose lateral faces are triangles with a common vertex join. So prism is named after its base. Thus a hexagonal prism has a hexagon as its base, a triangular pyramid has a triangle as its base, and then is a rectangular prism, then a square is a pyramid. In different solids we take out faces, vertex and edges. Then we get the faces plus vertex we do and edges plus true we do. We get the equal value. You can see in the cuboid there are the 6 faces, top, bottom, right, left and front, back. So 6 faces are there. 8 vertex are there. 1, 2, 3, 4, 5, 6, 7, 8. Then edges 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 edges are there. So 6 plus 8, 14. 12 plus 2, 14. Same way in the triangular prism we can see 1, 2, 1, 2, 3 front and bottom 4 faces are there. Then vertex 1, 2, 3, 4 vertex are there. And the edges we can see 1, 2, 3, 4, 5, 6 edges are there. So we can take 4 plus 4, 8 and 6 plus 2, 8. Same way in the triangular prism we can take 1, 2, 3, 4 and front 5. 5 is a surface are there. Then it has 1, 2, 3, 4, 5, 6 vertex are there and edges we calculate. Then 1, 2, 3, 4, 5, 6, 7, 8, 9 edges are there. So we can see 5 plus 6, 11, 9 plus 2, 11. So we can write F plus V equals to E plus 2. Means faces plus vertex equals to edges plus 2, which is known as Euler's formula for the relation between any solid's face, vertex and edges. Exercise 10.3 we have, can a polyhedron have for its faces 3 triangles? So first answer is no, because the polyhedron has the more than 4 or equals to 4 surfaces. So it cannot have a 3 triangles. As if it has a 4 triangles, yes it can have and a square base and 4 triangles we have seen in the square pyramid. So it is also can have. So can a polyhedron? So polyhedron have a 4 triangles possible, a square and 4 triangles are possible, but 3 triangles are not possible. Question 2 is there, is it possible to have a polyhedron with any given number of faces? So yes, because a polyhedron has the just more than 4 or equals to 4 faces are there. So if any solid is there which has more than 4 or equal to 4 faces are there, it is called a polyhedron. Now question 3 is there, which are the prism among the following? So prism definition we have seen top and bottom are the congruent shapes. So pencil and the box as the top and bottom are equal. So these shapes are prism. Now how are prism cylinders alike? So as we go on increasing surfaces of prism, it converts into cylinders, and so we can say that prisms and cylinders are alike. Same way how the pyramids and cones are alike. So we can, as we go on increasing and increasing surface of pyramids, it converts into the conical shape, and so we can say that pyramids and cones are alike. Is a square prism same as a cube? We can say no, because its edges are not equal, then it can become a cuboid also, and so we can say that square prism is not a cube. Question 6 we have, verify the Euler's formula for the given solid. So here top and bottom and 5 faces. So 5 plus 2, 7 faces are there. Top 5 vertex, bottom 5 vertex, total 10 vertex are there. And top 5 edges, bottom 5 edges, and on side 5 edges. So 15 edges are there. So we take F plus V, then 7 plus 10, 17, and edges plus 2 we take, then 15 plus 2, 17. Same way one more solid is given with the cuboid with the rectangular pyramid. So we can see that here cuboid has the 5 faces, because this top will not count. So 5 faces for lateral and bottom, and rectangular prism has the 4 triangles. So for that, so total 9 faces are there. Now here 4 4, 8 and 1, 9 vertex are there, and edges. So cuboid has the total 12 and here top 4. So 16 edges are there. So we measure f plus v, then 9 plus 9, 18, and e plus 2 equals to 16 plus 2, 18. Now question 7 is given using Euler's formula find unknown. So in first question, faces where numbers are not given, vertices are 6 and edges are 12. So we know that f plus v minus e equals to 2. Then f plus 6 minus 12 equals to 2. So f minus 6 equals to 2. So f equals to 8. The second question we have f equals to 5, vertices are not given, e equals to 9. Then again f plus v minus e equals to 2. So 5 plus v minus 9 equals to 2. So v minus 4 equals to 2. So v equals to 6. And here f equals to 20, v equals to 12, e equals to, we have to find. Then f plus v minus e equals to 2. So 20 plus 12 minus e equals to 2. So 32 minus e equals to 2. So e equals to 30. And the question 8 is given to us whether f equals to 10, e equals to 20 and v equals to 15 is possible in any polyhedron. So we check that f plus v equals to 10 plus 15, 25, while e plus 2 is 20 plus 2, 22. So we can see that Euler's formula is not satisfied, and so such polyhedron is not possible.